Here's example 5 of using double angle formulas. So this is going to be an establish the identity problem, and the identity is cotangent of theta minus the tangent of theta, all divided by cotangent of theta plus the tangent of theta equals cosine of 2 theta. Okay? So here's our double angle here that's going to come into play eventually. So remember the rules for establishing the identity type problems. The one thing that you always want to do in every type of problem like this is always just pick one side, work only on that side, leave the other side completely alone, and then just try to manipulate that one side to make it look like the other side. Okay? So, and another thing that you should almost always do is start on the more complicated side. So in this case, the more complicated side I think would be the left side, because we have subtraction, addition, and division going on here. Over here we just have cosine of 2 theta. So there's not a whole lot we could do with this right away. If we see that there are 3 on our formula sheet here, which if you want a copy of this, check the video description, there's a link in there to get a copy of this. So cosine of 2 theta, we see that there's 3 different formulas related to that. But if, you know, we could try those at first and see where it gets us, and it's really not going to get us anywhere where the next step will be obvious. So since this side is a little more complicated, let's try starting over there. And we'll see if that takes us anywhere. Okay, so cotangent theta minus tangent theta, all divided by cotangent theta plus tangent theta, equals what? Okay, so we talked a lot about establishing the identity type problems several videos ago. We did a lot of examples. And remember, one of the rules, or one of the things to try, it might not always work, but it's something that's not a bad idea to try, is convert everything to sines and cosines. And that might not be a bad idea here especially, because on the left side we have cotangents and tangents, on the right side we have cosine. So eventually we want to get to something with cosine. So let's begin by converting everything to cosine and sine. Okay, so remember cotangent is cosine divided by sine. So this is cosine theta over sine of theta. Then minus tangent, so tangent is sine of theta divided by cosine of theta. Okay, and then on the bottom we have pretty much the exact same thing, but with the plus sign instead. So cosine of theta over sine of theta plus sine of theta over cosine of theta. Okay, now what we can do is get common denominators. There's a couple different ways to think about what to do next, but the more standard way, which we'll stick to keep things, to make things not so complicated here, we'll just get a common denominator. So look just at the top and we see denominator sine of theta, denominator cosine of theta, and then same thing just on the bottom. So we'll treat these separately. So here's the top, the big top, and then the big bottom, we'll treat it separately. So what we're going to have then is, well, we'll write it in there. Okay, so then this, let's zoom in on that. So cosine of theta over sine of theta. So if we multiply this by cosine of theta over cosine of theta, we still have a minus sign in there. Multiply this guy by sine of theta over sine of theta. Okay, and then do the same thing here. Multiply this one by cosine of theta over cosine of theta. And then multiply this one by sine of theta over sine of theta. Okay. So why are we doing that? Well, the reason is that we want to get common denominators separately on the top and on the bottom here. Okay. So then what we're going to have is cosine theta, so that's cosine squared of theta over sine theta cos, well let's, okay, yeah, we'll just write it like that, over sine theta cosine theta. And then we still have this minus sign in here, so then what we have is sine of theta times sine of theta, which is sine squared of theta. And then we have cosine theta sine theta on the bottom. Okay, so that's this whole top right up here, that's that whole thing. And then that's being divided by what's happening on the bottom. Cosine theta, that's cosine squared of theta, all over sine theta cosine theta. And then we have that plus sign wedged in there. And then we still have sine theta times sine theta, which is sine squared of theta. And then cosine theta sine theta, just cosine theta sine theta. Okay, so it looks like kind of a mess, but it's really actually not that bad. Now, probably don't have enough room down there. So let's zoom out a little bit and we'll come back up here. So then this equals, now let's squish everything together in the common denominators. So sine of theta cosine theta, that is the same thing as cosine theta sine theta, so we'll just write it all together as one as sine theta cosine theta. So this is cosine squared of theta minus sine squared of theta all divided by sine theta cosine theta. Okay, and then so that's what's happening on the top, and then we're dividing that by what's happening on the bottom, which is cosine squared of theta plus sine squared of theta, divided by its common denominator, which is actually the same thing, sine theta cosine theta. Just remember, sine theta cosine theta and cosine theta sine theta, they are the same thing because it doesn't matter what order you multiply things in. Okay, so now we have one fraction divided by another fraction, so when you divide by a fraction, it's like multiplying by the reciprocal. So then what we have is the fraction on top, which is cosine squared of theta minus sine squared of theta, all divided by sine theta cosine theta, so that fraction on top, multiplied by the reciprocal of the fraction on the bottom. And the reciprocal of the fraction on the bottom is sine theta cosine theta, divided by cosine squared of theta plus sine squared of theta. Okay, so then, continuing, notice we have some cancellation going on here, that's great. So blah 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 divided by sine of theta cosine theta times sine of theta cosine theta divided by blah blah blah. So sine theta cosine theta cancels up here and down here. And then what we have is cosine squared of theta minus sine squared of theta divided by what's happening on the bottom now. Well, cosine squared of theta plus sine squared of theta, that is 1, right? This whole thing just equals 1. Remember, that's the Pythagorean identity, one of the most important identities in all of math. So we really just have cosine squared of theta minus sine squared of theta divided by 1, which is the same thing as saying cosine squared of theta minus sine squared of theta. Okay. But what is that? So if we go back to our formula sheet here, we see cosine squared of theta minus sine squared of theta. That is cosine of 2 theta. So this exactly equals cosine of 2 theta. And if we look back up to the identity we're supposed to establish, that's exactly what we wanted. Okay, we wanted cosine of 2 theta in the end. That's exactly what we just had, what we just got. So that's example 5 of using double angle formulas, and it's established the identity problem. So just to recap on a high level what we did. First, we converted everything to cosines and sines because it's one of the things to try. And in this particular problem, it makes sense to try that because we start with cotangents and tangents, but we want to end up with cosine. So let's, at some point, we're going to have to convert to cosines and sines. So let's just start right away doing that. So we did that. Then we got a common denominator. We combined everything with the common denominators. We simplified dividing by a fraction, multiplied by the reciprocal. So we did that. We canceled these common factors here, and then we used Pythagorean identity to simplify this. And then this is our double angle formula right here. Okay, so that's example 5 of double angle formulas, establish the identity.